All right, so this is what the functions are going to look like that we're going to be graphing soon. Um, I'm not going to actually graph anything in this video. We're going to wait till graphing till tomorrow, but we have to do all the setup stuff. Okay, the first thing you need to check for is something called a hole. And again, I'll explain everything tomorrow, show you what this looks like on a graph. Now, you find a hole. You first have to look at this and say, all right, let's factor this. So we're going to factor it. So there's nothing we can do at the top. So you factor the bottom. All right, so we have an x minus 2 and an x plus 1. All right, holes. Now let's identify some things here. Let's talk about. We're going to have holes and we're going to have vertical asymptotes. These two things are caused by division by 0. Division by 0, right? Just like we go back to unit number 1, where we can't divide by 0. All right, so these two things, holes and vertical asymptotes, are caused by division by 0. Now, even though this thing just has a hole, I'm going to talk about the hole and the asymptote, the vertical asymptote, in kind of one shot here, even though I think the next screen starts with vertical asymptotes. Okay, a hole is found where, if you look here, and after factoring, don't cancel anything unless you factored, that we could cancel this x minus 2 factor away. Now, of course, when you cancel things, these become 1s. So this will turn into 1 over x plus 1. Then you look at the canceled factor. Okay, now let's look at that. So the canceled factor was x minus 2. Now, in the original function, if you were to plug some numbers in there, you would see that a 2 would cause this to, say, bomb out, right? Or be a bad number. So if we solve this, we get a 2. That means in this original function that 2 can't be inputted into this function, or it's going to cause division by 0. So there's a problem with that. It can't cause division by 0. Something bad will happen. Well, that bad thing that happens will be a hole. So the hole will be located at an x value of 2, but now we have to find the y value. Now the problem with this is, how in the world do you find a y value of a hole? If you plug this back in, it will cause this to bomb out. Like, for example, if you put 2 in here, it'll get 2 minus 2, which is 0, and then 2 minus 0 here, and 2 plus 1, which is 3. So you'll get 0 over 0 times 3, which is 0 over 0, and you can't divide by 0. So what do we do? Well, we can actually find the y value of the hole by looking at what I call this new function. So here is a new function that is created by eliminating the factor that will cause the hole, and we're going to plug into that. So what we're going to do is we're going to find f of 2, but we're going to put f sub n for new, because we're going to plug into here. Okay, not into the original one, because that would cause that to fail. So let's plug a 2 into this. So we have 2 plus 1, and then 1 over 2 plus 1, which is 3. All right, so that number is going to go right here. So when we go to graph this, there's going to be a hole there. Now, I'll just quickly show you what that's going to look like. So if we graph that 1, 2, and here's 1, we're not going to put a dot there. We're actually going to put a small open circle, which would represent the hole. Now, the rest of the graph is going to go right through there. Now, I'm just making this up. This is going to look something like, let's just say the graph comes down here, it starts approaching the hole, and then it's going to kind of skip right over that hole. And maybe it's going to look something like that. I don't know. I just made that up. But that's what's going to happen, is that part of the graph is going to come up to the hole and then kind of pass right by it. And we have to put a little open dot there. All right, now since we're here, let's actually look for a vertical asymptote. So we found the hole will be located right here. Okay, let me just clear this. All right, so now notice that with the new function that we had, which is y is equal to, or f of x, what was that? Whatever was there, who cares? Was 1 over x plus 1. All right, so here's the deal with asymptotes. And this is vertical asymptotes. Is that you find them after removing holes. After removing the factor with the holes. I'm just trying to write fast here. And I think this is explained on the next slide here in a second. After removing the factor with the holes, you set denominator equal to 0 and solve. And that will tell you where the vertical asymptotes are. Because remember on the previous slide, I said that division by 0 causes holes and vertical asymptotes. Well, the only thing that we have left now is this x plus 1. Okay, so we're going to set that equal to 0. And we're going to get x is equal to negative 1. Now, this represents a vertical line. So we're going to leave it in this form. We have to write x equals negative 1. Whenever you have an equation that looks like x equals number, it's going to be a vertical line. And so this is now going to be our vertical asymptote. Now let me show you that quickly, what that's going to look like. On your graph that you do, you're just going to go to negative 1, wherever that is, and you're going to pop in a vertical asymptote at negative 1. And that's exactly what that would look like. All right, let's go to the next slide and see what that looks like. Okay, vertical asymptotes. So this is what I kind of wrote before, just kind of quickly, that once the holes are removed and the rational function is simplified, meaning this is when I find my new function, then we find the zeros of the denominator, meaning we set the denominator equal to 0, and we find our vertical asymptote. Okay, so let's do that. First step on all of these is to factor. Now in this one, there's nothing we can do on the top, so we have to leave that alone. And we factor the bottom into x minus, x plus 4, x minus 2. Now this top, since it does not factor, don't start canceling x's. You can only cancel factors, and I find that's one of the biggest, greatest errors that some of us have, is that we cancel incorrectly. Well, you can only cancel factors. If you look here, none of these factors match. So what we can conclude here, let's say we are actually going to do this problem. When it says holes, right, and you identify the hole, we're just going to put none, because nothing cancels. So that means, I don't know why I have this equals here. That means that there is no new function, that this is it. And we now only look for asymptotes. So now what you'll see is often I abbreviate the vertical asymptotes as VA. All right, so now we're just going to set the bottom equal to 0. So we need to set every factor equal to 0. And this one will actually have two vertical asymptotes. One will be located at x equals negative 4, and the other one will be located at x equals 2. So as far as vertical asymptotes, we are going to write x equals negative 4. We will also write x equals 2. There's no other way to write these. You can't just put negative 4 and 2, because you're literally writing an equation of a line, which has to include the x. Now, let me show you quickly what this would look like. And you're just going to put two vertical lines, one at negative 4, 1, 2, 3, 4, and you're going to dash that in, and one at 1, 2, and you dash that in. And that's what the two vertical lines would look like on that one. Okay, next. Once again, first thing we're going to do is factor. Now I see this has a GCF, so I'm going to pull the x out, and we're left with x minus 4. Okay, and on the bottom, it looks like this has a GCF as well. And then this turns into x squared minus 1. Now I'm going to continue factoring this on the bottom. I'm going to leave the top alone. And it looks like this factors into x plus 1, x minus 1. All right, so this then is our new function. Just kind of block that. Oh, that's not our new function yet. We haven't removed the holes. I'm getting ahead of myself because I'm trying to do this quickly. All right, so if we look at the factors, we have an x minus 4. I don't see any of those. The plus 1 and minus 1. The only thing that'll cancel are the x's. So I cancel that. And then I identify the holes. And let's just write our new function right now. So f sub n for new of x is x minus 4 over x plus 1, x minus 1. Okay, so there's our new function. And let's identify the holes. So the holes come from any of the factors that were canceled. So the factor that was canceled was an x, so you set that equal to 0. And this one's actually easy because there's no work to do after that one. I don't have to solve for x because it already is. Now, we have to find the location of the hole. And if you're not practicing this, I can kind of tell because then you'll just say, well, the hole's at 0. Now, that's the x value of the hole. We put that right there. Now we have to find the y value of the hole. If you remember from the last slide or so, we then go into the new function. So now I am finding f new of 0. And I'm going to plug 0 into every x I see up here. So 0 minus 4 over 0 plus 1 times 0 minus 1. And I'm going to simplify that. So on the top I get negative 4. And on the bottom we get a 1 times a negative 1, which is a negative 1. And that's going to give me an x or a y value of 4. So that goes right here. So my hole will be located at 0, 4. Now, this slide is called determining vertical asymptotes. Well, you have to remove the hole first. So that's why I went and found that. So I know that the hole is located at 0, 4. We now have to find the vertical asymptotes. The vertical asymptotes, let's do that over here. Let's say VA. You set the remaining denominators, all the factors, equal to 0. Since I already moved the x's, I am now only looking at this new function. And the only thing left there is x plus 1 and x minus 1. So I'm going to set those equal to 0. And I get x is negative 1. And if I set the other one equal to 0, I get x is 1. So the vertical asymptotes will be the two vertical lines, x equals 1, and the vertical line, x equals negative 1. Now, as far as this problem goes, there's a lot more to do, but for now, we only found the holes and the vertical asymptotes. All right, if you want to see what that would look like, I can do it here. All right, so the two vertical asymptotes. One will be at 1, right here. One will be at negative 1, and I'll put that in. And then there's a hole located at the point 0, 4. So you go to 0, 1, 2, 3, 4, and you put an open dot right there. And that's what that would look like. And again, there's a lot more to do with these functions, but that's where we're stopping. Okay, two last things we're going to look at. I'm going to save the horizontal asymptotes for tomorrow because those are pretty complicated, so I don't want to make the video with this. The last two things we're going to do is determining the zeros of a rational function, which are on the x-axis, and we can also find the y-intercept, which should also be pretty easy. So with this thing, I'm just going to walk you through all the steps and then show you how to determine the zeros in a second. So just like every other one, first step, factor completely. So we have x plus 2, x minus 2, and that's going to be divided by, let's see, that one's x plus 4, and then x minus 2. Okay, and then I'm going to have some answers over here, and I'll put holes because maybe there's more than one hole, and we're going to identify the vertical asymptote. We're going to identify any zeros that we have, and we're also going to identify the y-intercept. So this is going to be my answer box, and then everywhere else there's going to be some work. Okay, so step 1, look for holes. So, well, step 1 we factored. Step 2, look for holes. So I'm canceling the x minus 2. There we go. So let's do the holes, let's say up here. So the canceled factor, which will cause the hole, is x minus 2. So let's set that equal to 0, and we get an x value of 2. So I know that the hole will be located at 2 something, and I have to figure out what that something is. And in order to do that, we have to plug that into the new function. Since this is already canceled, I'm going to rewrite this as x plus 2 over x plus 4. Now, just to make everything fairly clear, everything else that I'm about to do is going to go into this new function. So I'm going to rewrite it. And I think you guys should rewrite it too. And by should, that means you better. So here's our new function. Everything else will be found from the new function. Because if you try to find it in the old one, things are going to go bad this day. Okay, so now we have to find, after the canceled factor, we have x equals 2. We're going to find f of 2 in the new function. Right? This comes right from the new function. Because if I plug 2 into this, you're going to get something undefined. So let's plug 2 in there. So we have 2 plus 2 over 2 plus 4. And that gives us, I'm going to run out of room over there, 4 over 6, which is 2/3. So I'm going to come right over here, and our hole will be located at 2 2/3. And I'll show you again what all this looks like in a graph when I'm done finding everything. Okay, vertical asymptotes. I will do that in red today. Okay, I'm going to take in the new function. Again, everything comes from the new function. In the new function, I'm going to set the denominator equal to 0 because that's where division by 0 occurs. It's in the denominator. And I get x equals negative 4. So I come back over here, and I write x equals negative 4. And I only have one vertical asymptote this time. That's okay. Now for the zeros. Let's do that. What didn't I do yet? Let's say green. Now for the zeros. Well, if you look at the directions up here, once holes are removed, so the holes have to be removed, this has to be gone, this has to be gone. You have to have the new function. Again, everything comes from the new function. Okay, any zeros of the numerator will be a zero of the rational function. And I'll explain this a little bit better tomorrow. So on this one, we're just going to set the numerator equal to 0. Set the numerator equal to 0 and solve. Because the numerator of my function is x plus 1. I'm going to set x plus 2. I'm going to set x plus 2 equals to 0, and I get x equals negative 2. Okay, well that's a 0, so we only really need the negative 2. We never really list out the 0 with that. We just write out a negative 2. Now, it does occur once. You can put a multiplicity of 1. On these, most of these don't have any other multiplicity, so I'm not going to write multiplicity of 1, but notice that it only occurs once. There's only one x plus 2, so we don't really need to write that. Okay, lastly, the 0, and then we're almost done. Oh, sorry, the y-intercept. Now, as far as the y-intercept goes, we should know that every y-intercept is the point 0 something, So all we have to do is find f of 0. And again, I'm going to use the new function right there. So f of 0, I'm going to plug that in, get 0 plus 2 over 0 plus 4. And that gives me 2/4, which is 1/2. So the y-intercept is going to be 1/2. And for now, that's it. There's still another thing that we have to do. We have to find horizontal asymptotes, but there's a chart that goes with that, and that is really, I think, the most complicated thing that we have to do. So I'm just going to let that go till tomorrow. For now, let's plot everything that we know so far. So, and I'll try to keep the color code here that I used in here. So let's go 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so in blue, here's my hole. It's going to be the point 2 2/3. So I'm going to come over to 2, 1, 2, and then come up to about 2/3, a little less than 1, and I'm going to put a hole. There it is. Vertical asymptote is in red, and I'm going to go to x equals -4. 1, 2, 3, 4. It's a vertical asymptote. I put a vertical line that is dashed right there. Next, 0 is -2. Well, just like every other 0 we've ever found, that can be found on the x-axis. So we're going to put a 0 at -2 right there. There it is. And the y-intercept, which I did in black. And that's fine. I think I'm out of colors anyway. And it is found at the point 0, 1/2. So that is at 0, 1/2, which is right here. And there you go. Now for tonight's homework, that's all you have to do. It may ask you for other stuff. Okay, but you're going to find these things in this order. 1, you factor and find the holes. Then you set the denominators equal to 0, which is the bottom of the new function, and you find the vertical asymptotes. 3, you set the remaining numerator equal to 0, and that finds the zeros of the function, and then you find the y-intercept in that order. Okay, make sure you write all that down. If you have any questions, let me know tonight, and that's all you're going to be doing for tonight's homework. For those of you that need to finish up the quiz, you're going to be starting that tomorrow, or finishing that up. I'm giving you 15-20 minutes tomorrow, and that's it. You're not getting any more time, so make sure you can finish in that amount of time. All right. If you guys have any questions, let me know. Otherwise, see you tomorrow.